Hello everyone and welcome back to the second episode of, the second video from Trace Your Packets. Today I'm going to go into a bit further about setting up a network. We're going to then do it basically two networks completely opposite to each other, and we're going to connect them together. While doing that, I'm going to cover a bit about certain protocols, not all of them. There's plenty to cover in documents and documentation. Trust me, Cisco's got plenty of student lab files for these sort of things, but I thought it'd be better to learn by doing. So in this, we're going to actually set up the exact same system I used before in the last episode, and we're going to add a further two routers. I'm going to spread these out a little further. I'm going to connect it up with another switch, and I'm going to connect yet another two PCs to that. And from there, we'll then connect all this up. Now, as I said in the last episode, you've got an automatic choose connection cable. I don't recommend using that all the time. The reason, pretty straightforward, is basically it's not always going to be useful. In this instance, actually primarily. So before I'm able to connect these routers, we don't want to be using the actual Ethernets to be able to connect routers together. It's good, but it's not as good as it can be. So what we want to do is we want to start off, we'll zoom in a little here, so we can see the device in the physical element. Now, because this device is powered on, as you can see, all three of them are going to be, we want to power the device off. So we're going to turn it off, which you actually have to press on it, which I think to this day is still pretty cool. We want a NIM-2T module, which is basically just a serial module. Once that is installed, which you just drag and drop from here, you can install two modules into this. If you want to remove it, just drop there. And then we want to power the device back on. Once that's done, just leave that and that'll power back on. And we need to do that to the other two now. So I'm going to quickly do that. Nice and quickly. Bump, bump, and bump. Perfect. So those now are connected. Now, as I said, there are different kinds of connection types. So we're going to use a serial DCE cable from here. So we're going to set 010 is going to connect to 010 on this side. And 011 is going to connect to 011 on this side. I like to do this just so things are pretty straightforward. I find it easier personally. That's just how I am. So this router we're going to quickly jump into. Ooh, this has changed a little bit from how I actually set it up. Let me just quickly jump onto here, go to font. I see, I accidentally changed that to blue. Apply that. That's better. So, as I said in the last time, we want to go into Conf-T. And first things first, I just want to change the host name of this, and this just could be called the ISP, or Internet Service Provider. That's going to be what I call this router. And you can also just press the little text underneath, and you can rename them there too. If you want to, it's just so you know exactly where certain devices are. It's a bit easier to find them then. Trust me, it's not always the nicest or the cleanest, but it's better to have it around than not at all. So what I'm also going to do is I'm just going to feed these here. That way, everything's sort of out of the way of each other and nothing's like overlapping all over the shop, as you can see, which is currently the issue we seem to be having. So I'm going to just put that there, stretch that out a little bit, stretch this out a little bit, and there we go. It's a little neater. It's not the best, but it's better than nothing. And this side I will do the exact same. As I said, just basically going to feed things through nice and neat, as neat as I can get it. And there we go. So the left side is the original. We'll actually call this our home network. You know what? We can actually, there we go, draw a rectangle. We don't want any fill. That's completely fine. So this will be our home network. And we'll have that just there. So just call this home. Oop, do apologize, that's me misclicking. This will be our, we'll just have that as like ISP, so that'll be general connection. And then this side is going to be our second home network. Yeah, we'll do it that way. Sure, why not? Oop. Press the wrong thing again. Always good fun. So that's ISP connection. And then we got this side, which is home 2. Cool. So, what we're going to do from here. Obviously, we set up last time so that these devices had IP addresses, and this also had an IP sat on this network. So, this time I'm going to set up the major router first, which will be the ISP router, and then we'll connect these straight to each other. Just going to move that more central. That way we know roughly where things are. Right, let's get this done. So, as I said to you last time, there are different interfaces. So, this time we do not have Gigabit Ethernet Gigabit Ethernet interfaces. We remove those. We know we've got serial interfaces this time, which is SE. So we want to first set up serial 010. So we want to go into serial, and then it will literally be the same as before, 0/1/0, and then we're onto that interface. Now, as I said, I'm not going to go too far into IP addresses yet. That is something that definitely does need to be gone over. I think, though, that's going to be an episode dedicated to itself. IP addresses and subnets can be quite confusing. There are many people who will explain it a lot better than I can as of the moment, which is why I want to wait for a better time to do so. All you need to really know at the moment is IP addresses are separated into different classes: Class A, Class B, Class C, Class D, and same with subnets. IP is your internet protocol. You have a private class and you've got a public class. Your private class is guaranteed to be something that's only on the internal network. So basically, that's to communicate inside the network. And then you've got a public class, which will be your external IP address. It's the one that everyone sees externally. So, for example, if I was to pull up, if I was to find out my external IP address, it would most likely be something, I can't say for certain, but it'd be a public class IP address. That would be my external showing one. It'd be what people use to connect to me. Actually, I do have a tool for this. We have an application that me and my friends use called Hamachi. So, if I was to open up Hamachi, I will have to cover the name, but that's fine. So, open up with this. You can see this here is my public-facing IP address. This is what people would connect to me with. Now, if I actually go onto here and details, this would be the IP address that's seen. If I had someone online and I was to talk to them directly, it would be a private-facing IP address that I'd be able to connect to them by. So yeah, you've got your private, which is your internal on your network, and then you get your public, which is usually your externally facing ones. That's the way I like to look at it. I could be entirely wrong, but that's the way I've always understood it. So anyways, so for this, we're going to use a private class, but a lot more of a smaller one because it needs more hosts that are possible to connect to, which is the reason we use smaller ranges. Basically, the smaller the IP address and subnet mask depends on how many devices can connect on that network. So I'm going to actually set up the IP. IP address is going to be 10.1.1.1 on this side. And the IP address is going to be 255.255.255.252. And that's important. The subnet mask of a 252 means that there can only be 2 IP addresses on that network. So that's fine. Then we're going to do no shutdown to turn that up, which is fine. So now we're going to exit that interface, and we're going to go into the other interface, which is serial 0/1/1. Then we're going to do IP address again, and we're going to do 10.2.2.1. That's how I'm going to do this one. And then that IP subnet mask is going to be the exact same of 252 ending. And then no shutdown again. Right, from there, we're then going to go to the other routers, because as you can see, there's still no connection. Now, there's not going to be honest with you. Oh, it looks like this one might have actually removed all my configuration from last time, which is fine. It's not really a problem. I can reset this up pretty quickly. So we're going to do hostname first, and this is going to be R1. Actually, you know what? We'll call it R1 home. Can't do that. R1's fine then. So with R1, we're then going to just quickly check, as I showed you last time, we're going to show run. Just make sure if there is any IP address on Gig Ethernet. There is not. So yes, that one has gone down. I should have actually noticed with the red lines there. You can see that's the same on both sides, so that's completely fine. So now we're going to do conft again. We're going to go to interface, gigabit Ethernet, 0/0/0, enter that. IP address 192.168.1.1, 255.255.255.0, enter that, no shut. Perfect, that's that IP up and running. So now we're going to go interface, serial, 0/1/0, enter that. We're going to do IP address. Now if you remember, on that side we did 10.1.1, so now we need to do .2 at the end. Simple reason being, we basically want to make sure that these two are on the same IP address range. Now as I said, the subnet mask of 252 at the end basically states quite clearly you are not able to have more than 2 devices, hosts on that. Each host would be one IP address. So with this, we can only have 2, and then we've got a loopback address. That's something I'll go into later, so you don't have to worry about that for now. But these 2 devices are the only ones that should be able to go on. So if I connected a third device on the same IP address range, this would turn around and reject it and just flat out ignore that IP. So that's fine. Basically for security reasons is the main reason behind that. And as you can see, that's gone straight up, which is exactly what we want. So I'm going to now jump off that. I'm going to go over to this one. I'm going to Control-C this, ENA, hostname. Sorry. Perfect. So that's ended. As you can see, this was my mistake. If you do actually want to end this, just put no IP domain lookup, and should be a hyphen between that, and that will basically just prevent that from happening again. So if I put, as I said before, I tapped in hostname, it's immediately ended. So I recommend doing that. It's a bit of safety. It's always good to have. So next, what we're going to do, because I forgot to teach you the most basic command last time, like a bit of a pillock, what we're going to do next is we're going to set up the interface on the gigabit first. So interface, gigabit Ethernet, 0/0/0, IP address. Now, as you saw before, we used the 1.1 range, so we're going to use the 1.10.1 range. And it's still going to be... actually, no, we're not. We're going to use the 2. There we go. I feel more comfortable with 10. That's fine. So that'll be the IP address, and no shutdown. Exit that. And next, we're going to go into the interface for the serial 0/1/1, IP address 10.2.2.2, 255.255.255.0, 252, enter that, and no shut again. Now, I should be able to, from here, if I exit all this, I should be able to ping 10.2.2.1. As you can see, I got 5 out of 5 pings perfectly, which is fantastic news for us. It means that this is working so far. I did forget to do the basic thing of hostname R2. There we go. So now what I'm going to quickly do, because I forgot to do this last time, I'm so disappointed with myself. When you're in ENA mode, type write, that will build the config. Basically all that's doing is you're saving everything you've just done, which is what I forgot to do last time, which I can't believe I forgot that. Absolutely disappointed in myself. I have done this so many times over the years, and I have never once forgotten this. So you might notice sometimes I'll be in like the middle of confinf. So if I do actually go interface serial, and I can jump straight to ENA. Reason I do that is Control and C, and that's able to jump straight back. So just a nice little way if people want to speed things up. So I'm going to quickly now set up the IP addresses for these ranges. So I'm going to go in here. That will be 192.168.10. Let's go 10 again. So that's 0. The default gateway here is going to be 192.168.10.1. And then with that, that's saved. And then I'm going to do the same on this, but just slightly alter the IP address. 192.168.10.11. And then, once again, 192.168.10.1. Then we exit out of that. Just make sure that these are set up correctly. These are just missing their IP address. So that default gateway will be 1.1 on both of these devices. And now, tell me, with this, considering these are connected, do you believe that I can send a ping from this router to this router? Because they're directly connected to each other, realistically, so there shouldn't be an issue. But if you notice, something is preventing it. And there's a reason for that. 10.1.1.1 does not exist to this network. It doesn't make sense for it to. It's very similar to if I was basically to jump onto here, jump into command prompt, and even though this is connected to that router, I can ping 192.168.10.1 with no issue. Or at least I should be able to. I'm scaring myself now. What's wrong with you? You're literally connected there. What's wrong? Oh, what's happening? Let me just check something here. Go run. 10.1, that's correct. That's up. That's 000. Yep, that's all fine. You should be able to ping. What's wrong with you? Send a mail from there to there. Hit play. It reaches the switch, that's fine. It then sends one either way, and both got rejected. How unusual, considering this side made it just fine. Oh, wrong thing here. Let's say I do it on this side then. Ping 192.168.1.1. It splits them off just in case. That side's accepted it for some reason. Now that's received it. Are you going to play correctly though? Yeah. So this one's receiving pings. This one's rejecting pings. How interesting. You know what? Let me try from this machine, just see. Ping 168.10.1. Okay, so that's still rejecting it as well. I'll definitely have to have a look into this. This is not correct. 1, 2, oh, I see. That was my fault. People are going to be screaming about that. Gigabit Ethernet 000 IP address 192.168.10.1 255.255.255.0. What I did wrong, if you can see here, I had 192.1.10.1. That was my mistake completely. I really did mess that up. I do apologize. So ping that. You can see that's completely fine. And this IP address here is 10.2.2.2. So realistically, even though they're on the same network, I should be able to ping them. But, oh, actually I can, because they're on the same device. So that's perfectly fine. But what if I was to ping the ISP router that's connected through 10.2.2.2? As you'll notice, I can't reach it. Now the reason for that is basically the router knows how to basically when PC sends out a ping, as you saw before, it was sending it out, it was splitting both ways to check which one of you is called this, and it realized this one isn't, cancel the packet. This one is, perfect, accept the packet. Now neither of these devices are called, well, associate with 10.2.2.1. This device does not know that 10.2.2.1 is based on this side of the device. The reason for that is we've never told it is. If I open up router 2 and I show you the config, you can see clearly in here that there is information about this being 10.2.2.2. You cannot see, though, on the other hand, that there's anything to do with 10.2.2.1. It sounds a little complicated on the surface, but effectively what I'm saying is there is no street sign in here to tell it to continue on. And that's the problem. Because there is no sign to tell you to move and continue, it doesn't know where to go next. So what we need to set up is a protocol called OSPF, or at least that's the protocol I'm going to show you how to set up. OSPF, or Open Shortest Path First, is a way of basically configuring your router to tell any ping or request that comes through where to reach another device. So the way we're going to do this is we're going to open up conft, and we're basically going to say where other devices are based on the network. Now, I'm going to run this quickly because this has been a little while since I last ran OSPF. I used to be very confident in it. Nowadays, it's a bit more all over the shop, but I'm hopeful. So, what we're going to do, after we've configured our IP addresses, which we clearly have, and things definitely do work, which is always a happy day, we're now going to set up OSPF. Pause here, Rory. Continue from here, Rory. Right, so what we're going to do is we're going to enter OSPF. So, router, OSPF, these are the other modes, by the way. So you got routing information protocol, open shortest path first, which is what we're going to use, EIGRP, enhanced interior gateway routing protocol, and border gateway protocol, or BGP. This one you will probably never use in your life unless you get very, very good, because this basically controls the global infrastructure. So we never really want to touch that. So in here, we're going to call it OSPF1, and that's going to be our protocol for this. So Next, we need to specify what the network areas are. If you are a little bit confused, what we're going to do is we're going to press question mark to start with. So then we're going to be able to see what there are on the network. So we want to enable routing on an IP address network, which will be pretty important for us. So we're going to type in network, and then we need to state what the network will be. So we want the network address. So we want to say that 10.2.2.0 and then OSPF wildcard, which will be 0.0.0.2. And then we're going to set an area, and then the area will be 0. Oh, I have messed something up here. Oh wait, 252, so it's actually 3? Yes. So the reason for that is, if you remember the subnet mask we set up ages ago, the subnet mask ends in 252 for this bit. So 0.0.0, because there are nothing left. The maximum number you can have is 255. And then 252 take away 255 is 3. So that's how that's set up. And then we're going to do network 192.168.10.0 and then 0.0.0.255 area 0. Once that's set up, we're then going to move on and set up the same on the other networks. Oh, actually, no, we'll just try this first. There might be something else that we'll have to come back and do, but I'm hoping not, to be honest with you. ENA, conft, router, OSPF, 1. This number needs to remain the same across all the devices. If it doesn't, it can cause so many problems. I don't recommend it. So let's move on. So now we want to do network again. Now we want to set up, remember there are 2 different types of networks. So we're going to do the 10.1.1.0 network, 0.0.0.3, and that'll be area 0. We've got the exact same, but except these are 2s. Now, that should hopefully be it. I don't believe it is, though. I do believe we've also got to set up the others. I'm going to wait, though. Oh, you can see there, the OSPF is set up correctly. So now I'm going to go over here, ENA, conft, router, OSPF, 1, network, 10.1.1.0, 0.0.0.3, area 0, and then network 192.168.1.0. Just press tab if that ever happens to you, because sometimes they'll overlap and you'll continue typing. It's a bit confusing, so just press tab and it'll bring it all back. Then it's 0.0.0.255, area 0, enter that. And now, I should realistically be able to ping to 10, oh, sorry, just realized what I've done there. So I'm going to exit out of them now, and I'm going to try and quickly ping 10.2.2.2. As you can see, I can ping that IP address with ease. It's made it all the way round without issue. Now the question is, can I ping these IP addresses? 192.168.10. Let's say 11. Can I ping this? Or is it going to get stuck? It made it. So now, realistically speaking, I can ping. Actually, you know what? We'll do this in simulation mode. We'll select a packet. It's going to go from this computer here all the way across to this computer here. And we will hit play. and you'll be able to watch the packet in real time. So it's this packet here. As you can see, it's moving straight on. Here we are. It's finally reached the next stage. Now it's moving on to the ISP switch, because it knows where the next stage is. It's then checking, right, where would it be from here? Oh, I think it might have failed, but it might not have. We'll find out in a quick moment. What we can always do, though, worst case scenario, oh, it's sending it back. So what I'm going to do now is I'm just going to open this up again, and I'm going to try and ping this and just see. Yep, that can make it with, oh wait, that's going to that one. My apologies. As you can see, I'm able to ping from PC3 all the way to PC0, which is this one down here. Now, if I wanted to change it, oh, sorry, that is not correct. That's PC0. Now I can also ping PC1, which is this IP over here. These now can all communicate with each other across long distances. Now, this can quite literally be of, it might look this small scale, but it quite literally it can be like this across large networks. I'm showing it you on a much smaller scale than what it would typically be. As I said, it is not the easiest thing to understand, and it can be a bit confusing at first. But these are some of the commands that, to be honest, back when I started, I did not understand what they did. I wanted more detail, and that's kind of what I'm trying to give with this. It's not perfect, and I can assure you, as I continue, I will get better at it. But this is the starting point I'm going with for these episodes. If you do find any help with it, or if you want to add anything, because these are for new starters and for people that aren't very confident at the moment, please do in the comments. I would much appreciate and much prefer people to expand upon the knowledge and continue. I'm trying to give my opinions from when I started, but I know things aren't going to be perfect. So please, feel free to add to what I say, or even correct me if I am wrong. I'm more happy for that to happen. But this is just a little play around with Cisco Packet Tracer, just to show you what you can do, truly, in this. And I hope it does help people, and it gives a bit more information. But OpenShut is path first, allows me to tell the network where to send files to. It's basically, as my tutor once put it a long time ago, you're basically saying, send this letter to this address. And you're giving it to the postman, who needs to know the delivery address and how to get there. So basically, you're just setting up his GPS as well as telling him where the address is. And that's all you've done. Please let me know if this helps. If you need any more help, feel free to reach out either on here or directly message me. I'm more than happy for either option. But yeah, thank you very much for watching, and we will see you next time. Bye for now.